From a giant factory furnace to the fridge in your own kitchen, our whole world really runs on precise temperature control. But have you ever stopped to think about what's actually doing the measuring? Well, today, we're going to pull back the curtain on the tiny, unseen sensors that make all of that possible.
Okay, so first things first, we need to get our heads around the basic problem these things solve. And let me tell you, this isn't about just checking the weather. We're talking about measuring the unmeasurable. In places where getting it wrong, well, that's just not an option.
Seriously, just think about it for a second. How on earth do you measure the temperature inside a roaring blast furnace? Or, on the flip side, inside a super cold scientific freezer? You can't just stick a regular thermometer in there, it would be instantly destroyed. Obviously, there's got to be a better way.
And the answer, in a lot of these really high-stakes situations, is a little device called the RTD. That stands for Resistance Temperature Detector. It sounds kind of simple, but trust me, it's a seriously clever piece of engineering.
So what's the secret sauce? What makes this little sensor so special? To really get it, we need to take a look at what's happening on the inside. At its core, the design is actually pretty simple. An RTD is basically just a superfine wire made of a pure metal. We're talking things like platinum, nickel, or copper. It's all wrapped around a core and tucked inside of a protective sheath. The secret isn't some complex machine. It's all about the basic physics of that metal wire. And this is the key to the whole thing. These pure metals have a property called a positive temperature coefficient. Now that sounds super technical, but it's really just a fancy way of describing a simple, predictable relationship. As the metal heats up, it gets harder for electricity to flow through it. In other words, its resistance increases.
So it all boils down to a really simple three-step process. 1, the temperature around the sensor goes up. 2, that causes the electrical resistance in that pure metal wire to increase. And 3, a little instrument measures that exact change in resistance and, voila, it converts it into a super precise temperature reading. It's just a really elegant and reliable system.
Okay, but the RTD isn't the only show in town. It's time to bring in a new contender, one that plays the game with a totally different set of rules.
So, while our RTD is all about pure metals, I want you to meet the thermistor. The thermistor is built from semiconductor materials, and right there, that fundamental difference is what gives it a completely unique set of pros and cons. Well, this brings us to the obvious question, right? If you need to measure temperature, which one do you pick? Let's find out. It's time to put them head-to-head in a good old-fashioned sensor showdown.
All right, first round, accuracy. And right out of the gate, we have a clear winner. If you need absolute pinpoint precision, the thermistor has the edge. It's just plain more accurate than the RTD. So, round 1, that goes to the thermistor. Next up, speed. And guess what? The thermistor takes another round. If you need to know about a temperature change the second it happens, the thermistor's quick response time is exactly what you want. The RTD, well, it's a little slower to react. Now that speed is absolutely crucial for something like a medical thermometer, right? But for a giant industrial kiln that takes hours to heat up, not so much.
So it looks like the thermistor is just running away with it, right? It's more accurate, it's faster, seems like a done deal. But this is where the story takes a really important turn. We have to ask the one question that reveals the RTD's hidden superpower.
And here it is, the RTD. It can handle a mind-numbing -200 degrees Celsius all the way up to a scorching 850 degrees Celsius. This is its world. We're talking industrial furnaces, cryogenic labs, the real extremes.
Okay, now let's look at the thermistor again. Its range, it's way, way smaller. We're talking roughly -55 to +114 degrees Celsius. I mean, that is a massive difference, and it changes absolutely everything.
And this is why it all matters. That huge difference in range basically decides where each of them ends up working. The RTD is the heavy-duty industrial workhorse. It's built for places where stability across a massive temperature range is way more important than a split-second response. But the thermistor, its precision is perfect for the cozy, stable temperature range of, say, your refrigerator, where keeping your food at exactly the right temperature is the #1 job. So, after our little showdown, what's the final verdict? Who wins? Well, it's really not as simple as one being better than the other. Let's just recap real quick. The RTD's superpower is its insane temperature range, which makes it a must-have for heavy industry. The thermistor, on the other hand, wins on accuracy and speed, and that's why you find it in all sorts of everyday gadgets we use at home. So at the end of the day, there is no single best sensor. It's all about engineering, it's about choice. It comes down to picking the right tool for the right job. I mean, sticking an RTD in your fridge would be total overkill, and putting a thermistor in a steel mill, yeah, that would be completely and utterly useless.
And all of this leaves us with a really fascinating question to think about. As our technology, our computers and phones, gets smaller and more powerful, it also runs hotter than ever. That means the demand for tiny, tough, and super precise temperature sensors is only going to skyrocket. So you have to wonder, what new kinds of physics will the next generation of these invisible little gadgets rely on?